Hi gang, here's an example from section 3.4, and in this section you're asked to develop quadratic models, so basically parabolas, in some kind of problem situation, and then often use the fact that a parabola has a maximal or minimal point at its vertex in order to solve an applied problem. So here's number 16 in section 3.4. Norman windows. A Norman window has the shape of a rectangle surmounted by a semicircle of diameter equal to the width of the rectangle. So basically a half of a circle on top of a rectangle. And you can see this picture they include. If the perimeter of the window is 20 feet, what dimension will admit the most light or maximize the area? In other words, the perimeter, all the distance around the outside of the window, including the exterior dimensions of the rectangle in here, and also this half circular arc, this semicircular arc here, so that all of the outside dimension of the window is a total of 20 feet, and then we want to flex the window or design the dimensions so that it'll have a perimeter of 20 feet but a maximum possible area. Okay, let me drag my version of the problem over here so hopefully my photo will get out of the way. Maybe I'll open this up a little bit. So here's a picture of our Norman window. This is a half circle on top. So the basic picture is what I've got in black here with a given radius. And then do a little bit of work to figure out what the other dimensions would be as in terms of R. So with the single variable R, you can figure out that the dimension of the base of the rectangular part of the circle will be 2R, will be a diameter of the circle, or 2R. The top semicircular arc, well, since the circumference of the circle is 2 pi r, half of that is pi r. That'll be pi times r, that curved length up here. And then a little bit trickier, but not too bad to figure out where I'm getting this. If you want to figure out this dimension, take the full perimeter of 20 feet that's given, and then subtract off pi r for the circular arc up here. That's part of the 20 feet, right? So if you want to figure out how much is left, take the full 20 feet, subtract off the length of the arc, and then also subtract off this length down here, right? And what's left out of that 20-foot perimeter is the amount of perimeter that goes into these two vertical dimensions here, these straight vertical dimensions. So if you take what's left and divide by 2, that gives you the height of the rectangular portion of the window. Okay? Okay, so with those dimensions, now we want to figure out what dimensions will maximize the area, right? Okay, so the area of the rectangle, or the area of the window now, is going to be the area of the half circular part on the top plus the area of the rectangle, right? The area of this half circle plus the area of this rectangle is the area of the entire window. And of course, then just to build this function, the area of the half circle, full circle is pi r squared, is the area of a circle. Take half of that, half pi r squared is the area of the half circle. And then the area of the rectangular portion down here is just going to be the product of the dimensions. You know, area of a rectangle, sorry about bouncing around here, is width times length. So take 2r, multiply it by this vertical dimension, sorry again, and you get, come on, settle down, you get 2r, the length of the base, times this dimension. Simplifies a little bit with the canceling of 2, distribute the r, and then notice that what you've got here is 1, 2, 3, 4 terms, a constant times r squared. Pi is just a number, about 3.14, so a constant times r squared plus a constant times r plus a constant times r squared plus a constant times r squared. So it's just 4 terms, and 3 of them are in r squared and 1 of them is in r. So let's collect up the r squared terms, just add all of those coefficients on r squared and simplify a little bit. You get this, plus another 20r. And it's at that point that you see this is really a formula for the area. It gives the area of the circle, area of the window as a function of the radius, function of r, in this format. And here you can see that it's really going to be a parabola because it's second degree in r. It's like ax squared plus bx plus 0. It's got a number times r squared plus a number times r plus a constant term of 0. So that's a quadratic function. And we actually know from looking at this leading coefficient, -2 minus pi halves, that's a negative number. Remember, pi is about 3.14, so this is, -3.5 or something like that. The leading coefficient's negative, so this is going to have a graph, this area function that is a parabola opening down. Here's a rough sketch. Basically, if I've got the r-axis here, and this is the y or a of r axis, this is going to come up. Actually, it's not too hard to see that there'll be an intercept at 0, 0. And it's going to be a parabola opening down, and of course the vertex is up here at opposite of b over 2a, and then a of whatever that is would be that vertex point. And the point is here, if this graph gives area, the maximum area of the window is going to be right here. And we're supposed to find the dimensions of the window that's got a perimeter of 20 and a maximal area. So it's going to happen when the radius is equal to opposite of b over 2a. Here's a, here's b. Okay, continuing. So the first coordinate of the vertex is opposite of b over 2a, and I'm plugging that in here. There's my a. Opposite of b is opposite of 20. And then I'm just simplifying a little bit to get this in the cleanest form. The radius of 20 over 4 plus pi, that's the value of the radius that gives the window its maximal area. And then just taking that 20 plus 4 pi and substituting it back into the dimensions that I had before, substituting it back into the red text here, 2r and 20 minus pi r minus 2r over 2. Takes a little bit of work, but it's just math 95. You get 40 over 4 plus pi as this dimension, and 20 over 4 plus pi as this dimension, approximating about 5.6 feet and 2.8 feet. And of course the radius is also at approximately 2.8 feet. And that would give you the maximum area. In the problem situation, they didn't actually ask for the area. Although you notice we've got everything here, we would need to calculate that if we wanted to. Okay, bye.